Perfect. So I'll mention about what we have done this semester, but I just wanted to start from the beginning, maybe also take you in a memory lane a little bit since I've been joining the project and get back to the present, also refresh our memories. So the goal of our project is to develop a model that can create multi-factor investment portfolios. The reason we wanted to create a factor portfolio is diversification through different asset classes, or even in the same asset, diversification through sectors is not enough in turbulent times because according to a Fidelity research paper, it showed that in those turbulent times, these seemingly uncorrelated different sectors tend to move in the same direction. So that's why in that paper they were arguing that diversification through factors are a better way to diversify your risk in these turbulent times. And in their paper, they were mentioning a portfolio based on the factor risk diversification performed better. I think it's clear to establish that why we are, you know, troubling ourselves with factors. So they are extremely important when constructing a stock portfolio. And the factors that we're going to use are Fama range factors. And our goal is to achieve our target factor exposures so that we can create a portfolio that works as that's caters to our uh, investment goals. Um, Oh, okay. So let me briefly mention our model. How do we achieve that? So obviously we gather historical data and we format it in a way that our optimization model is going to understand. And what we do is we have our factor returns at the right-hand side, and on the left-hand side, we have our uh, returns and weights of the possible stocks that we're going to have in our portfolio. And we also have an additional term called error term, which is actually we want to write it in an absolute value format, but when writing it in mathematical formulation, this is the way to do it because otherwise it's not a linear program. So this is how we achieve it. So we minimize the error terms. So our target factor exposures and the factor returns and the difference between our optimal portfolio is extremely little. So this is how we achieve it. Of course, we have many more constraints that's required to construct portfolio, but we just wanted to show the core of the project. And this is some example results. So for example, the absolute difference is extremely little in our compared to our target and the optimization model that gives us. So this is really good. This shows that the model is working as intended. And I just want to show the factor correlations. As you can see, they are extremely small, the correlations. So this is good. This is doing what it's supposed to do through the diversification. So this is so far, this is what we have known so far, and we've already presented these before. I wanted to go into the next slides and explain what we've done this semester. So up until the last slides, we constructed our portfolio and we were done with it if we wanted to be done. But of course, every portfolio needs to be rebalanced or, taken care of in the future after it's constructed. It can be because of changing investment philosophies, changing market environments, or other reasons. So we wanted to be able to prepare for it. And obviously, if we want to just change our portfolio, have a different philosophy, we can do it with our current model without needing introducing features which we have done. I'm gonna get to it. Our model can reconstruct an existing portfolio to achieve our new target factor betas based on our market views. But if we like our portfolio and just want to be able to hedge against large event in the market that's maybe pose a risk to our portfolio that's not related to the systematic things that happen in the usual times, but like the war, the conflicts, natural disasters, these kind of things. These are unforeseen events, and yeah, we may want to be prepared for them. So that's why we introduced the futures hedging to our project. It also eliminates the transaction costs associated with buying and selling assets at rebalancing at all times. If our portfolio is large enough, this could save us a lot of money, of course, minimizing the transaction costs. So how did we do this? So we have our project has the three factors in the form of French three factor model. So in addition to the market factor, we have the size and value factors. So we needed to find an index futures in the market that trades to hedge against these factors. Obviously, finding it for the market factor, it was easy. S&P 500 has an index futures with the CME group. So we used that to calculate the hedge ratio. So as you guys can see, the hedge ratio here is very high, 0.91 for the market factor. So this is pretty good. And when we test it for different time periods, it will go to 0.95, 1.05, or something like that. But for the latest backtesting that we've done, this was the result. So I just put it up there. The finding suitable index features for the other factors were not that easy or successful. The best results we got for the size factor was 0.80. It's not too bad for the hedge ratio. It could work, but we would have wanted to be better to represent the sensitivity between the factors returns and the index features returns. But this is still usable. Unfortunately, we couldn't find a suitable index to hedge against the value factor. The best result we have gotten so far is 0.4, which is extremely low, and it cannot be used to hedge that factor. That doesn't make sense. And hopefully, in the upcoming months, our new undergrads to the project will try to look out for indices that's gonna be suitable for these two factors, and then we can use it. Once we calculate the hedge ratio, we will. Okay, why can't? Okay, then we can start our hedging. We can create our hedging function and hedge our whole portfolio or parts of our portfolio, and this is how we did it. Actually, the function that we wrote is just not just for hedging. It can do also leveraging. I remember in our previous meetings, this was a talking point that we should have explained it better. And Jordan, you were asking why would we need to increase why would the target beta might be higher than our current beta if we're hedging? We should have explained that better. But yeah, so this function does not just do hedging, it can do leveraging, but for our purposes, we're only going to use it for hedging. Maybe if the project evolves, it can be used to do leveraging and try more stuff. And the procedure we followed comes from the John Hull's options, futures and derivatives textbook. We strictly followed the mathematical model that he had when calculating all of the steps inside this function. And as a result of this, this is one of the results. So if we had a portfolio with the market risk of 1.1 market risk beta of 1.25 and wanted to hedge it, we would short 8 contracts over the next 4 months, which is our hedging period. And yeah, we would gain 42,000 around $42,000 from this position, and our loss from our portfolio would be negative 35,000, and the total gain loss is around $7,000. I just want to mention, for now we haven't done mark to market, which is actually required for using futures. So that might be a next step to implement, if we want, if we just go below the margin, and we would need to add capital to that account. But yeah, it's definitely something that we can take a look at it in the future. So it's great. For this example, we have a positive return in our example. The positive return is because of our portfolio did better compared to the market. So because we hedged our market risk with the futures, that takes away the sensitivity to the of the market. So the only performance is our portfolio's returns relative to the market. So this means that our portfolio lost less than the S&P 500. So that's the reason we don't have it here, but the reason for that is we had a higher size beta compared to the S&P 500 or the market, and it had, when we checked the historical returns, the size factor did better for our backtesting period during that time. So we captured the premium that the S&P 500 did not capture because of their low exposure to the size factor. And yeah, so we always go back to see and why did our portfolio perform better. I think it's important to understand the reasons and not just accepting the positive or negative values here. So it was great to reassure ourselves, yes, we captured something that the broad market did not, and that's why our portfolio performed better in this situation. And yeah, and our team is also working on some other stuff with, automatizing these processes and presenting them in a single Excel file so that it can be better presented to the potential people that we talk and that may be interested in our projects, want to learn more. So yeah, with this, I can conclude the presentation and I can take questions from Jordan, or if you had